Thank you very much. It's a terrific and humbling honour to be here today, and I'd like to thank my nominator, Professor Len Sharker, for providing this opportunity. It's addressing the same three questions today about a bit of my background, 2030, and where we might contribute. My background, my PhD is in atomic physics, originally actually at James Cook University. But I did part of my PhD at the Clarendon Lab at Oxford, so very early on I got a very clear idea of culture shock, particularly going from James Cook to there, not only growing up in Cairns, 17 degrees south of the equator, and then going to somewhere where you had to put these 20 pence pieces to keep the heater going, that was a shock. Probably second only to when I had to start wearing shoes to school at the age of 13 and going to high school. That was terrible. Wonderful way to grow up though, and the first R&D experience I had actually kind of bookended my career. It was a wonderful experience, far north Queensland, beautiful tropical beaches, stringing up a phased array radar, and then sitting back and changing the discs, back then the Winchester discs every 4 hours, having a cold beer, thinking if this is research, I'm really good at it. This is something I can do. And strangely enough, I ended up running a laboratory where the most beautiful radar in the world, one of the most extraordinary RF instruments on the planet, is called the Jindalee Over-the-Horizon Radar System. Quite an extraordinary instrument. I wish every Australian could go out and see one of those sites. I ended up running the division that ran that radar. So strangely, it was bookended by Over-the-Horizon Radar. My background is 30 years in defence science. A lot of it in area called electronic warfare. That's where you detect signals, intercept signals, jam signals if you've got a missile coming towards a ship or an aircraft or something like that, and signals intelligence. Wonderful times there, diversity of technologies, a lot of RF photonics, in fact, doing 40 gigahertz, 40,000 megahertz RF photonics 20, 25 years ago. Systems made here in Australia which couldn't be beaten in the world at the time. Setting up one of the first femtosecond laser labs associated with ultra-fast ADD conversion at the time. We were looking for the fastest controlled man-made phenomena, and back then it was optical pulses. It's a wonderfully diverse experience. Ended up actually setting up some UAV systems and things like that, and then eventually I had the privilege of running the research and development for countermeasures development and electronic support, what's called electronic support for the Royal Australian Air Force. So all of the aircraft survivability equipment, I ran that program. Spent a couple of years in the embassy in a diplomatic position there as Counsellor of Defence Science. It was a wonderful experience. Working in the huge machine that is the US Department of Defence. Spent a lot more time looking at culture than ever I thought I would, and the cultural differences between why the American system is the way it is and why the Australian system is the way it is. I thought it would be, and it was, a technological playground, but I spent much, much more time looking at culture as a fundamental thing we need to look at. And then finally, the privilege of coming back and being chief of what's called the National Security and Intelligence Surveillance Reconnaissance Division. Again, the thing I learnt there was diversity. Wonderfully privileged to run a program that ran from phased array radars and the Jindalee Over-the-Horizon Radar to computational linguistics, teams of psychologists, sociologists, computer scientists all working together to do extraordinary things. Hyperspectral, RF, just wonderful privileged experience. Then, about a year ago, I jumped ship out of the government creche, and I wanted to learn more about industry, the way the real world worked, and so I was fortunate enough to become director of Lockheed Martin's Stellar Lab, the first US lab they've established here in Australia. So I've got probably a little bit of a different perspective to a lot of people. The importance of mission, to me, is critical. It is an absolute privilege to get up every morning and apply science and technology to the defence of Australia and its national interests. That's really, really important. And so that sense of mission, that sense of pride in your mission, no matter what it is how do we instill that? How do we get that early into the up-and-coming generation? The international perspective is absolutely critical. We are a small nation with porous borders in a world that's uncertain. So we can't do things alone, and nor should we even try. We should be reaching out as far as we possibly can to team with the best. And that was a very, very strong lesson, I think, from those years. I spoke before to culture. If I had to choose one thing that is the biggest strategic mismatch between our nation, us and the US, it's the understanding of science and technology, which leads to the next point. If I look at our US brethren and other nations, the lack of understanding in Australia of the strategic importance, the critical strategic importance of science and technology as a strategic policy issue, I think is lacking. And from my mind, if I look at any of President Obama's speeches and compare them to any speech in Australia, it stands out. So I think that the technology as a strategic, empowering thing for the nation is not as well understood as perhaps it might be, and I'd like to be able to contribute to that conversation. Finally, I've had an immense privilege of leading smart, well-funded teams, and I've never ever come across a situation where Australians can't just be absolute world leaders in a really smart way. It's not just shoot it with the money gun, it's doing it smart, and it's an immense privilege to lead those teams. The photos there are kind of, again, bookending my career, was autonomy. I've done a bit of work in autonomy, and the top photo there is a hovering missile decoy system called NOLCA, developed by Defence Science and Technology Organisation. It's a missile that actually stands on its end, so balancing a pencil on your finger. It's the strangest rocket in the world to watch it flying around Woomera, just dancing in the air. It's a thing of absolute beauty. It's protecting the major service combatants of the Australian Navy, New Zealand Navy, the US Navy, the Canadian Navy, $1 billion worth of exports for Australia. Wonderful Australian invention. And the last one, really proud of, we started in the division our little CubeSat programs. And our first one, Biari, went up a couple of months ago, and a whole pile of satellites went up a couple of months ago, and Biari was amongst them. I was really proud of that. But my other little one, Buccaneer, went up last week with much less fanfare, but she's up there now doing a bit. So kind of bookended by autonomous systems, one in space and one actually very close to the sea surface. It's kind of cool fun. Towards 2030. The Stellar Lab, where are we going to go, and what do we think is important? Clearly there's areas which have come up before. Analytics, I think, is an incredibly important area for the nation. Space is going to be incredibly important for the nation. It's really cool to be working for the company that's going to be taking mankind to Mars. I reckon that is just cool. And what can we be doing more in that conversation? Australia has all the talent we need. There's probably something of an incoherent conversation around that area, which again, would be great to be able to contribute to. The other areas which I think are important at 2030, and I don't know enough in this area to know how to navigate the Australian path, but I would like to work with the Academy to assist us learn how we do this. But the other one's energy. Lockheed, actually, most people would be surprised to learn, is $1 billion a year energy company. Everything from miniature nuclear fusion R&D, all the way to bio-waste, waste from energy from waste products. And again, what is right for Australia? I just don't know. What we have learned in our sort of very, very short foray so far is that the waste energy one has as much to do about waste and management of waste and our precious land resources as it is to do about energy. So that's been, for me, has been an eye-opener. Contributions, this is my kind of understanding from reading this ATSE strategic plan of the key strategic areas and some of the challenge questions that we're facing. I think there's a couple of areas that really, I think, we can bring across. We need to combine together. I think the STEM education, the whole thing about the pipeline to me is very, very important. So there's a lot of things we need to do with industry now to make it Industry 4.0 ready. There's a lot we could be doing with the pipeline, and what can I be doing? I'd love to be able to contribute to that part of the mission. And in the challenge question missions, there's a lot of threat and potential social dislocation associated with autonomy. We know that. But I think unlike a lot of the other revolutions, there's a lot of potential for planning for the impact of that, and how can we apply that technology in a considered and early way for social inclusion type things. So I think there's an intersection there of an opportunity and a threat, and I think that's a really important conversation that if there's a chance I'd like to be involved in. Thank you very much.